Hey guys, Miss Fisher. Happy Tuesday. I'm going to be walking you through the module online here, so I'm going to jump right in because this one is kind of lengthy. It's got a lot of good examples, and hopefully this helps you out. All right. So if we get into our modules, go to home and do modules, and obviously this would be lesson 8 from Unit 1. And it's pretty critical, so please make sure that if you don't understand this, you're asking questions during class. You can email me, I'll try to hook you up. And there's all kinds of videos on this specific lesson. So if you literally type up, open up lesson 8 from Unit 1, they will pop up, okay? So again, I'm going to skip the warm-up because we're going to do that in class. I'm going to get to the Desmos piece. So if I get to next, we'll talk about that one in class. All right, so the Desmos, okay? And I'm going to enter my class code. I'm just going to use first period. That's S, XJ, QY. Okay. And there's going to be multiple ways of thought here, so really utilize what you can and whichever method works best for you. Okay. I have a favorite method I was taught when I was a kid. All right, so it says we're taking this little quad down here, and we're gonna try to decompose and rearrange this triangle to find its area. So we found objects that were rectangular, the area of those. We found the area of a square, and we found the area of parallelograms so far. You really should be familiar with those. If you're not, you need to hit the books and study, or you can come see me on Thursday for tutoring at 8:30 in the morning. So Thursday at 8:30. Okay. So there's two ways of thinking. Yesterday's Desmos, we took the triangles, we made a mirror image, like a copy of that, an exact copy. We rotated it, and then we found that it could make this object. So if you took this is one way of thinking, okay? So if I wanted to find the area of that triangle, I could make a copy of it, turn it on its head, rotate it 180 degrees like we did yesterday, glue it to the other one. That forms, in this case, like a square. So I know it says to make a rectangle up here, but a rectangle really is kind of like a square. A square is sometimes a rectangle, okay? So in this case, we have a triangle on top of a triangle. Well, if I know that this is a square, I know how to find the area of a square. I just literally take 1, 2, 3, 4. That's its base, right? And I take 1, 2, 3, 4. That's its height. Or you could say this is its base and that's its height. We've already learned that. So the base and the height, you can make whichever your little heart desires, okay? Regardless of the fact, it's 4 times 4. So the area of this whole figure would be 16, okay? But how much of the original thing were we looking for? Well, we weren't looking for the whole object. We were looking for half. Well, this triangle was half of that square, rectangle, whatever you want to call it. Well, its original area was 16, but we only had half. Well, that would be 8. So I'd say my area is 8. Miss Fisher, that really doesn't make any sense to me, dude. I don't get it. Well, you could decompose the shape. You can break the shape up into pieces. So I'm going to cut this little triangle off. See this little triangle here? It's 2 tall by 2 wide, and I'm going to place it upside down over here. So what I'm referring to is I'm going to take that triangle, and I'm going to move it right here. It's another way you could do it. Regardless of the fact, the area does not change. And again, I moved this triangle. I cut this off with my virtual scissors, and I moved them over here. Because the area is not changing, I'm just moving the shape around. Well, it's still 1, 2, 3, 4 by 1, 2. So if I did that, 2 times 4 is still 8. The area of that triangle is not going to change. You could have done it up like this. You could have taken this triangle on the bottom and moved it up here. You could have cut this one off with your virtual scissors, this little guy right here. And you could have moved it up here. That would still give me 4 is my height. My base is 2, or it's 2 rows of 4, still 8. There's a lot of different ways to do this, okay? This one asks to do the same thing, so you could, there's a bunch of ways. We've already shown 2 ways. So there's method 1 we could have done here. Method 2 we could have done there. Method 3 I could have doubled the triangles and put it there. So this is really the same thing. Describe how you found a second rectangle. So in reality, guys, I showed you 3 ways to do it here. You're only going to show 1 way. On this next page, you would show another. So if I chose this on my first page, see how it's up top? My second one, I could say, well, I doubled it. So I could say on this one, I doubled the triangle. There's a lot of ways you can find area. Lots. Okay? I doubled the triangle in this one. That's a second method. So you'd say, I made a copy of my triangle. I decomposed and rearranged it where it became a square. I took half of the square's area. On this one, you could say I decomposed the triangle, I cut off part of the triangle and relocated it, making it a rectangle. The rectangle's area was 4 by 2, so it was 8. And that's where I'm looking for your conception. Okay, it's new. It's going to take some practice and watching videos. So drag the colored corners, rearrange it, find the area. So again, here's one method you could choose. You could take this, you could double the triangle. This is the way I was taught as a kid, and I always found this is the easiest way because I would just double it. So I double that, right? It makes a rectangle. Well, it's 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. Remember to count the squares, not the lines. So 8 times 4 is 32, right? So 1, 2, 3, 4, 4 by 8. But I only want half. I wanted to find the triangles area. So half of that 32, if I take this guy away, right? Half of that 32 is now 16. Ms. Fisher, that's confusing me. I don't get it. So decompose it. Cut off part of it. Well, I know that this is 2 and this is 2. I could literally take this triangle right here, this piece, this triangle right there. I could cut this off. I'm going to take my virtual scissors, cut it, and then I'm going to relocate it over here. It's the same exact shape. Remember, it's congruent if it's parallel. Well, in reality, if I were to extend this line out, right, it's the same shape. It's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2 is still 16. So regardless how you attack this thing, and that's what I'm looking for, is what object or what choice did you, there's a lot of ways you can do this. There's probably unlimited amounts of ways that you can do this. And then you would explain your reasoning. So I decomposed and rearranged, or I made a copy of this. I made a copy of the triangle. I generated a large rectangle, and then I cut the area in half. There's a lot of ways you can attack this. It takes practice. You're not going to learn this in a day, guys. So I know we're moving through material quick, but this is what the district just sent to me. I'm trying my best to hook you up by giving you some video help here. Okay? So again, here's method 1. I got another right triangle here. Right triangles are easy because you can always make rectangles and squares out of them. We learned that yesterday. That's what we were looking for. So I doubled the area, or I'm sorry, I doubled the triangle and made a copy, turned it into a rectangle. So 1, 2, 3, 4. And it says make a different. So this is the same shape as last one. Okay, so I could have done that. I could have made it down here again. Lots of different ways. I could have put this up here if I wanted to. Could have done all kinds of stuff. Okay, so I could have put this if I would have cut it. This is a little bit different with these bad boys here. I could have done that. I could have taken this triangle, cut it off, put it up here. 1, 2, 3, 4. By 1, 2, 3, 4, it's still 16. So regardless of the fact that the area of that triangle is not going to change. It's just how you're breaking the shape up and how you see it. Question 5. It's goofy, but I still see my 90. So you see the 90-degree angle. It's kind of like tilted over. But if you kind of like bent the shape, so if I took this, right? I took this guy. So that's the triangle we're dealing with. If I relocated this, I know this is over here, right? So if I took this guy and I relocated him up there, it's really the same triangle, but I would have to relocate my bases over here. Oops, that's the wrong way. It's really the same. Sorry guys, this thing's touchy. So take this over, take this over. It's really the same triangle. So I wouldn't suggest doing that this way in this problem. What I would do as a kid is, I know it's from here to here. I would extend these pieces out. So I got my dot there, right? I got my dot here. I got my dot there. I'm going to make a copy of this and extend it out. So just as long as the lines are parallel, there's my rectangle. Okay. In this case, it is kind of difficult to like, well, Ms. Fisher, I don't get it. How far is the distance? You're going to have to know some advanced mathematics there. So I wouldn't really attack this one using that. Okay. So the doubling doesn't really work on the grid here because that would be pretty challenging. Okay. What I could do is I could decompose and rearrange. So this little sliver right here, this guy right here, right? I could decompose and rearrange. So this little sliver, where would that fit if we're making another triangle? So if I were to take this sliver off and put him on the other side, I could relocate it right here. So I can slide this guy off, put it right there. So this sliver then became this sliver, so it matches. But then I would have to take this triangle, this one that's over here, and glue it down on the bottom there. So if I were to take that off, right? This would be my new object. So I would have to drag this guy down and then this guy over. Oops, there's a second dot. It's really the same shape. Okay? So there's a lot of different ways you can do that. And then I'm going to try to cheat with you guys a little bit today and show you guys formulas and all types of stuff. But we're going to do this in class, guys. And this is kind of, it's a little challenging, but it's not impossible. It's hard. It's take practice. That's period. It's just going to take some practice. All right? Same thing. Here's my next one. Ricky made this rectangle from the orange triangle and found an area of 20 square units. So 20 square units. Did he do this correctly? What advice would you give Ricky? So did he do this correctly? Well, let's find out. So this triangle, he's saying, he cut off and put glued over here to make it a rectangle. Let's see if he did it correctly. Is this triangle here congruent with this triangle? So remember, he's trying to find the area of this triangle, this orange triangle. So is this triangle that he moved, he said, I moved this and put it over there. Would that be correct? Are they congruent? Well, I could look at this and say this is 1, 2, and this is 1, 2, 3, 4. But this is 1, 2, 3 squares wide. 1, 2, 3, 4, 5. So what I would suggest telling Ricky is when you move parts of the triangle, they have to stay the same. Okay? So this triangle would have to be the same as this. So he would have to, if he wanted to do that, he'd have to find an equivalent cut. So he cut this incorrectly. He was close, but we're not playing horseshoes here. We're not trying to get close. So you would say I would move it to where it stays equivalent. Okay, we're talking about this in class today. So if you have questions, you can go back and watch the videos. Drag the colored corners to make up a rectangle that could be created by cutting up and rearranging. So again, here's my shape, right? And it's 1, 2, 3, 4, 5 on this side. It's 1, 2, 3, 4, 5 on this side. So it's a isosceles triangle. It's equivalent on this side and this side. Well, what I could do is I could just take this bad boy, cut off the other side of that triangle, decompose, and rearrange it. And we got some of these lines messed up. So again, you're going to have, and you might have a little homework on this guy. So I've taken this triangle off, if you notice, and I've glued it right there. I've taken that one off. Okay, so in reality, this guy is 1, 2, 3, 4, 5. This guy is 1, 2, 3, 4, 5. So 5 by 5 is 25. Okay, if you don't like that, you could also do this. So the area that this triangle would be 25. This guy now, I could make a giant rectangle go outside the figure, right? Because we can find the total area here just by going 1, 2, 3, 4, 5. It's 5 units high. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 10 times 5 is 50, but I don't want these two triangles. I don't want this one, and I don't want this one. Well, if I were to subtract those, pretend that this triangle here, see this guy right here? That triangle right there, plus this triangle over here, literally make that shape. So if I had 50, I would need to subtract, and this is a little harder way, I would subtract this triangle and subtract this triangle. Well, those two triangles together make this square. Well, what's the area of the square? 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5 by 5 is 25. Well, 50 minus 25 is still 25. So again, it's new. This is not an easy concept. So it's not like grade school where you just go to class, you learn a thing once, and you go on. You're going to need to study if you don't understand this stuff, guys. It's your conception of area. And again, we're covering this in class today, so try your best. All right, I have time for like one more. Drag the colored corners to make a different one. So again, you could have cut this a different way. There's all kinds of ways we could have attacked this. Okay, so I'm going to skip this guy. Isosceles, drag the colored corners to make a rectangle that can be created by cutting up and rearranging. So same thing, we have a different triangle, right? So I could decompose it and cut it in half. I could cut this bad boy right in half, like this, and rearrange. And my dots are in the wrong spots here. This guy, this guy, this guy, this guy. So it takes a little practice here, but I've taken this shape off, this triangle, I rotated them around, and I glued them right here. It's the same exact object, guys, as far as area. Well, to find that, I would say 1, 2, 3, 4, 5. By 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5 is 40, right? But I would want, so I can glue these two pieces together.